Welcome to this tutorial. I'm solving question number 9 of paper 2 to October-November exam series of 2022. The topic of this question is the nuclear atom and the half-life. Question says protactinium-234 is a radioactive isotope of protactinium that decays to uranium-234. Compare the nuclide notation of protactinium with the nuclide notation of uranium and deduce what this shows about what is emitted from a nucleus of protactinium as it decays to uranium. Now, the nuclide notation of protactinium is 23491, which means that when it undergoes radioactive decay, the element formed has a proton number 92, but the nucleon number is the same. So the proton number is increasing by 1, but the nucleon number remains the same. And this happens when there is a beta emission or beta particle emitted from the nucleus. Because in a beta decay, a neutron changes itself into a proton and an electron. So the proton number increases by 1, but the nucleon number remains the same. So it means that protactinium is undergoing beta decay. Place a tick in the appropriate boxes of table 9.1 to show what is deduced from comparing the nuclide notation. So as far as alpha particle is emitted, we would tick in the column of no. A beta particle is emitted, yes, it is emitted. About a gamma ray emission, it is not possible to tell at the moment. We would need more information, or we will have to investigate it whether the gamma is being emitted or not. In a gamma emission, we know that the nuclear composition does not change. So whether a gamma ray is also being emitted is not clear from the given information at the moment. The most abundant isotope of protactinium is protactinium-231. Explained by referring to their nuclear compositions why protactinium-231 and 234 are both isotopes of the same element. So they are the isotopes of the same element, which makes them the atoms of same element, is that they have same number of protons. That is why they belong to the same element. Explained by referring to their nuclear compositions why protactinium-231 and 234 are different isotopes of that element. So what makes them different isotopes is that they have different number of neutrons, which makes their nucleon number different. Otherwise, if they would have also been the same, they would not have been the isotope. A teacher places a radiation detector on a bench in a school laboratory and switches it on. The teacher measures and records the background count rate. Describe what is meant by background radiation and state two significant sources of the count rate recorded by the teacher. It is the count that is always present. So it cannot be eliminated because it is the radiation which is present in the environment of the surrounding. So regarding the sources, uh, it could be building materials which contain radioactive sources, and it could be cosmic sources like sun or the space. The teacher moves the sample, a sample of protactinium, so that it is next to the detector, state one precaution that ensures that the sample is moved in a safe way. So one precaution could be that keep a large distance of separation from the source. It would reduce the hazards and the damages caused by the radiation. The count rate is measured every 20 seconds with the sample present and then corrected for the background radiation. Now this correction is done by subtracting the background radiation from the value which is observed from the count rate. Figure 9.1 shows a graph of the corrected count rate against the time for the protactinium sample. The curve is the best fit line, so we can see that the crosses are not on the curve always, they are scattered. So a line of best fit curve is drawn here. Explain why many of the crosses do not lie on the curve. So the reason for this is that the radioactivity or the radioactive emission is a random process. That is why the readings or the measurements fluctuate. Sometimes they increase, sometimes they decrease. So this fluctuation is because of the random nature of the process. The next part says using figure 9.1 determine the half-life of protactinium. Show your working. Now this graph would be used to find the half-life for this substance given. The curve, as we can see, is starting at a value of 58 over here. So the first point being observed when the time is 0, there is a count rate of 58 counts per second. Now when we uh, divide it by 2, so after the first half-life, the count rate is going to be equal to 29. So I would select the value of 29. It would be between 28 and 28 and 30 over here. So I'm making a horizontal line till the curve, and now I would match this line with the horizontal axis, and the value that we are getting is 68 over here. So the second point on the curve is 68, 29. Now when we further half this count rate after the second half-life, it would be 14.5. So for 14.5, the value would be somewhere here. So again I would be drawing a horizontal line to match this point with the curve. It matches somewhere here. So the value we obtain is approximately 138 over here. Now when we further half this value 14.5, we get the count rate equal to 7.25. Now another value of the count rate would be required here. So it should be it is the value of 10, 8, 6 and 7.25 would be somewhere here. So now I'm matching this point with the curve with a perfectly horizontal line. the point that I get is here, and when I match this point over here, 208 approximately. So we got 4 points during this activity. This point is 138, 14.5, and the last one is 208, 7.25. So these are the 4 points that we would use for the calculation of half-life. Okay, so I've written all the points here. Now when we use these 2 points and find the value of the half-life, we get the value of the first half-life is 68. Then when we use the second and the third point, the value we get over here is 138 minus 68 equal to 70. Now when we use the third pair, the value that we are getting is 208 minus 138, again 70. So these are the three values that we are getting: 68, 70, and then 70 for the half-life. To find the final value, we are going to take an average of these three values by adding them and then dividing them by 3. So we get 208 divided by 3. So the answer is 69.33, which expressed when in two significant figure is equal to 69 seconds. So the final answer for this part is 69 seconds. The next part says the uranium-234 formed from protactinium is also radioactive. Its half-life is many thousands of years. So which means that it is radiating at a very slow rate. That is why it is having a very large half-life. Explain why the radiation from uranium does not affect the count rates measured in this experiment. Uranium decays very slowly, which is evident from its very large half-life. So the radiations detected are all due to protactinium. So the count rate is not affected by the radiation from uranium. The question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.